Hey friends, hello everyone. I'm currently near the office of AERONOVA. Indeed, my name is Gennady Babanin, but you can just call me Henry. I'm not an employee of the company, but as an involved, concerned, and engaged stakeholder and investor, I want to see what's happening in the company today. By a lucky chance, I indeed managed, so to speak, to ask to go to the company's office with my comrade in arms. I want to ask questions to the leading specialists, find out the details of what the company has achieved in the first 6 months of the project's life, and learn about the upcoming plans. As many know, on March 4th, the project moves to the first stage of its development from the pre-launch phase, and I would like to know what the plans are for the near future and what has already been accomplished. I sincerely hope that you find it interesting and engaging. Please do like and comment. I'll definitely do my best to try to drop by here more often and more frequently to keep both myself and you updated on the latest and most important news and events, and we'll keep a closer and more consistent eye on the project as well. I won't keep you or myself waiting any longer, so let's head into the company's office and chat with the team. Now we are right here, directly in the office of AERONOVA. The last and only time I was actually here was in November after a big conference in Moscow. Back then, at that time, the office was still quite empty. Let's see what's here right now. Come on, let's take a look and see what we can find. Vadim Vasilievich, first of all, I want to thank you for taking the time to answer a few of my questions. Vadim Vasilievich is our chief designer at AERONOVA. As far as I know, the launch of the first airship Nova 1 is undoubtedly planned for the near future.
This is still an unmanned airship. We deliberately and intentionally went for the creation of an unmanned airship because we needed to experiment with some ideas that we would later transfer to the manned airship, just on a smaller airship. In fact, this airship that we're building is the first manned one, called Nova 2. This is a 2,000 cubic meter, 6-seat vehicle, and we've decided to build an unmanned copy at a scale of 1 to 2.5. So in terms of length, it's 2.5 times smaller, meaning it's about 17 meters and 28 centimeters long, and the volume is accordingly 8 times smaller, so it's around 131 cubic meters. It's likely going to be several devices. I don't really know how many, but they will mainly differ in the design of the envelope. Yes, there will be quite a significant difference. There will be several devices. We are currently planning to put together the first device at this stage in March. It is primarily intended for testing our control system. So as you can see, you saw that we have a simulator which will also serve as the operator's workstation. We want to check how convenient it will be to control this device from this workplace, and if the pilot has sufficient controls or not, whether they are positioned comfortably for him, whether the information on the instrument panels is displayed well, if everything is readable, and once we verify all of this, it will be easier for us to create a real manned device.
Friends, Alexander has kindly agreed to share a little bit more about his work. Alexander is involved in prototyping, if I understood correctly. That's right. A few words about your work. What are you currently doing? Right now, at this moment, we're currently making a mechanical valve for the aerial vehicle, a small unmanned one which is going to be launched soon in the near future. First, a detailed and intricate 3D model is developed in the support system, which is a comprehensive and automated design system.
Then we print it on the 3D printer using our advanced technology. Here we have the state-of-the-art 3D printers. We seamlessly upload the file directly from the computer via Wi-Fi, and it prints immediately right away. Then we assemble it on this table.
And a tiny bit more about the role of this valve. It will release excess pressure.
So there are basically two different valves in the airship. One is on the gas volume, specifically on the helium, and the other is on the air volume. So the role of the valve that is on the gas volume, on the helium, is to release excess gas in order to prevent issues if something happens. This is more of an emergency situation because helium needs to be conserved. And the second one is on the air volume, where they constantly work in conjunction with the fan, meaning it maintains a constant pressure throughout the entire volume. If the airship changes altitude, then the gas in the main volume either decreases or increases in volume, while the air volume serves to maintain constant pressure. So the fan works, then the valve works, and there's this interaction happening. We also test them here. We have our own stand. It's definitely a receiver, a big, roughly speaking, bubble. It's stored here. We can set it up right here in this very hallway, and we can completely fill it up with a bounce fan, ensuring it fits perfectly. It's like a simulation of the shell. We hang it up, pressure is created, we measure it, and the values from the sensors are sent to the computer. So we can even assess the suitability of the valve right here. Yes.
Friends, we also have engineer Sergey, who is also involved in prototyping and plays an important role in the project. A few words about what you do. What interesting developments are you currently working on?
I'm working in a team with Alexander, who is a skilled engineer in our engineering department. I understand he has already told you most of the details and has been working on this project for several months. Right now, I'm specializing in the fan that will be installed on the unmanned airship to ensure optimal performance. And there's also a device in the system to stop the flight, which we will be testing as well, and functionality as part of our comprehensive evaluation. How will it function roughly? There will be a radio transmitter here that will receive the signal, approximately speaking. And in the event of a potential emergency, such as an electrical issue, a signal will be sent to it, and an electrical current is carefully applied to the nichrome wire. There will be a membrane here that will simply burn through. Accordingly, an opening will be created, like an emergency valve, and the pressure in the shell will be released. The fan for filling the shell is working.
The air is coming from there like a blower?
Yes, indeed. When there is a downward movement, the pressure drops, and in order to maintain the properties of the shell, it needs to be supplemented with air. On the contrary, during ascent, a valve is used because the atmospheric pressure decreases, which causes the shell to expand, and pressure is released through the valve.
Friends, I was incredibly fortunate to have the opportunity to meet with Dmitry today, a remarkable individual who graciously agreed to demonstrate and explain in detail the operation of the airship control emulator. Dmitry, a quick comment. Is this a tool that allows, as I understand it, to learn how to pilot an airship, or does it perform any other additional functions?
At the moment, yes. This is a system designed for training pilots to operate the airship. In the coming years, this sophisticated system is set to be developed with precision for the remote control of airships. It will also act as a vital training resource for pilots, offering them the chance to practice.
Is this completely your development? So we actually put together all of this literally ourselves?
The whole point, yes, in essence, indeed, it was assembled by us, utilizing various programs, a ready-made solution on which, yes, we applied our development that could be used for our tasks.
I know there have been several launches of balloons recently. Could you please share the detailed results of these initiatives with me? I am particularly interested in understanding what you were hoping to achieve by launching them and what specific goals and objectives you were pursuing.
Yes, now that we've started working with AERONOVA, I've gotten others interested in this work. So we're currently carrying it out with the involvement of specialists, students, and an initiative group that has set up the production of the shells. In the near future, with the emergence of our advanced production capabilities, we also want to start manufacturing high quality and durable shells for both airships and balloons, as well as other related components. For now, we want to tackle the challenges of long flights at high altitudes.
Friends, we have Boris Alexandrovich Ivchenko with us. Unaware, this is the head of the design bureau of the company AERONOVA. What are you currently working on actively? Any news, perhaps? What are the tasks for the near future in the pipeline?
We are currently in the process of trying to conduct tests very soon in the near future with a relatively small unmanned model of an advanced and innovative airship that has a volume of approximately 130 cubic meters in order to effectively work out some various state-of-the-art technological innovations that we want to apply in the cutting-edge NOVA 2, which is a highly anticipated project. This is a manned vehicle, approximately 6-seater, and with a volume of 2,000 cubic meters. So, the technology we want to work on there is a digital control system. And this is the ground landing technology, which will reduce the number of ground support personnel needed during landing and takeoff. This advanced system is designed to enhance operational efficiency by minimizing the need for human intervention during both landing and takeoff. These are basically the two main technologies that we essentially want to work on, which are fundamental and crucial in our projects and initiatives with the smaller models.
We're working very intensively on NOVA 01, which is 130 cubic meters. And of course, we're also working on NOVA 02, because if we don't work intensively right now, what airship can we even talk about by the end of the year? Right now, we're currently in a very focused manner designing the power unit, specifically the gondola and the rear steering system, as well as the air gas system. We're developing a new fan specifically designed for this airship, a new valve indeed. This is something being created specifically for this model. Right now, work is ongoing, and I can't even say which device we're focusing on more intensively. We're currently working on both in the most intensive mode. We're also starting to slowly work on the next project, but it's still very preliminary. We're taking the first steps in that direction. We are in the initial stages of planning and development for the upcoming project. This means we are very much planning that everything will be continuous. That is, what we have worked on the smaller device, we will transfer to the larger device, and the larger device will have added functions and capabilities, and we will move step by step towards a bigger airship, as we stated in our development plan for the company AERONOVA.
So what do we have in the end? The company has 750 square meters of office and laboratory space and 600 square meters of production space. More than 35 highly experienced specialists are working on the next generation airship project. Equipment has been purchased. The project involves the Moscow Aviation Institute, the Bauman Moscow State Technical University, as well as the Dolgoprudny Design Bureau. The first unmanned airship Nova 1 has been developed with a volume of 130 MEM3 and a length of 17 meters. Launches of aircraft into the stratosphere have been completed. A new control system has been created for onboard systems and the ground dispatch complex. The development of the second airship, Nova 2, with a volume of 2,000 M3 is also underway. The financial goal for the pre-launch phase has been achieved. We've raised $2.5 million in investments. What will happen next? The company AERONOVA has big plans. We talked about the final development of the airship Nova 1, and its launch will take place in March. Several modifications of the 130 cubic meter unmanned airship will be created for exhibitions and advertising purposes. There are plans to search for and purchase a plot of land for the construction of a hangar. Plans include developing and starting production of the second larger airship, Nova 2, with a volume of 2,000 cubic meters. I want to point out that on March 4th, the project will move into the first stage of its development. The conditions for investing will change exactly. The investment share will double in price. You won't be able to indeed increase your share like you could in the previous project, and the bonus of an additional 5% on the referral reward will also be closed. Friends, that was the main information I managed to gather for you. I will continue to keep an eye on the company's news. See you in the next videos.